Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to just walk through convergence tests for series. So what we're looking at here is number 22 in the book. I'm using sum from n equals 1 to infinity of n plus 1 over n squared root n. All right, when testing for convergence, first thing I usually recommend people do is identify is it a friend or a foe, meaning is it a friend, meaning is it a geometric or piece series. So this thing is neither. It's not a geometric or a piece series. Next thing we usually test is whether or not the a sub n's go to 0. So this thing is the a sub n. It's pretty easy to show that as n goes to infinity, that thing does go to 0. That means it might be convergent. That does not guarantee convergence. Right? If that sum was not 0, that would guarantee divergence. Another type of test we could apply is integral test. We could try to compare this against some sort of integral f of x dx from 1 to infinity. However, looking at this, I don't think it's too horribly bad, but I don't think we want to try to integrate x plus 1 over x to the 3 halves dx. Actually, that would be actually reasonably easy to do. Both integrals would be power integrals, but I think rather than that, I think what I want to do is compare this to, I'm going to compare the a sub n of n plus 1 over, I'm going to go ahead and write that bottom as n to the 2.5 power, I guess, 5 halves. And I'm going to compare that to a b sub n of just n over n to the 5 halves, which is 1 over n to the 3 halves, I believe. Yes? Now, the sum of 1 over n to the 3 halves from n equals 1 to infinity is fairly easily shown to be convergent because that's a piece series with p equal to 3 halves. So this is a convergent piece series. So now what we want to do is just compare that piece series to our original series here, and I think the easiest way to do that is going to be by ratio. So what I'm going to do is take a look at limit as n goes to infinity, and I'm going to take my a sub n, n plus 1 over n to the 5 halves, and just divide it by b sub n, 1 over n to the 3 halves. And this is going to equal limit as n goes to infinity. Let's see, up top we're going to have n to the 5 halves plus n to the 3 halves over n to the 5 halves. And I got that by taking this fraction and multiplying by n to the 3 halves over 1. And as n goes to infinity, this part of it goes to 0, but this part of it goes to 1. So, because we have a limit equal to 1, these two summations need to follow suit. They either both converge or both diverge. We just showed that the sum of the b sub n from 1 to infinity is convergent. Therefore, this original sum converges. Hope this video helps demonstrate these concepts. Have a great day.